Assalamualaikum warahmatullahi wabarakatuh. My name is Alia Batrisha binti Muhammad Najib. For this project, our group that consists of members, including me, will explain about process control and instrument in urea and ammonia plant. So, as the first presenter, I will explain about the introduction. First of all, this paper focuses on the controls of urea and ammonia manufacturing using DCS because automation has become vital to increase production feasibility that help to minimize human errors. So the initial stage in the production of nitrous chemical products such as fertilizers, explosives, polymers are based on ammonia synthesis. So this ammonia synthesis process, it requires a high pressure where high power multi-cycle compressors are employed to deliver the needed pressure. So this process includes the direct synthesis reaction of nitrogen and hydrogen that occur at equilibrium in the column to get highest conversion rate. So this highest conversion rate can be determined by related parameters such as temperature and pressure and also catalyst activity. So by this, the activity that occur in the column can be estimated and utilized for control using DCS. Next, I will pass this presentation to my other group members.
Okay, Assalamualaikum and a very good morning. My name is Nova Adila Zainuddin and my metric number is EA 00864. And today I will explain to you about variable of storage tank that we need in ammonia plant. Okay, for the first one, ammonia usually kept as liquid in refrigerator at -33.3 Celsius and at atmospheric pressure, and this tank frequently double-wall and have tonnage of capacity. But then there are two main categories of tank. The first one is single-wall steel tank and double-wall steel tank. And the usual tank that they use is double-wall steel tank. But then in this tank, ammonia gas is vented to keep the temperature low. But then, in case of a large amount of ammonia has been released from the tank, the temperature will be dropped as a result of liquid evaporation. Ammonia has a highly energy to quickly form into the vapor, but then the temperature will be dropped. But temperature of ammonia pool can be maintained by rate of heat transfer from environment till it is sufficiently close to its atmospheric pressure boiling point, and that the variable of the storage tank in this ammonia plant is just pressure and temperature. And that's all from me. Thank you.
And now we go to instrument for variable for urea and ammonia plant. Since the journal have mentioned many instruments that they use, we will explain one by one. At first, they use object analysis and design software engineering proposal to model distributed digital control system of power plant. They use failure mode and effective analysis (FMEA) process for detailed and systematic examination of the operation. Object-oriented analysis and design (OOAD) has been an efficient software engineering approach to model system as group of interacting objects. Next, the researchers have implemented the control system for an acid solution formation plant and April DCS system, which is Linux-based system. On April, both batch and continuous process can be executed. For controlling the plant, the logic and algorithms are applied in safe, manual, and auto mode. After that, the authors have used DCS using ultrafiltration, ceramic membrane filtration for a sewage treatment which has 3 layers. First, operation station, second, field control station FCS, and the last one, field instrument layer. Visual Basic is the application software of sewage treatment which is adapted by block-based design. And the last one is Presence OLE for process control (OPC) and DCS to connect simulation system, as well as in order to get data shared by various industries. By this, for the training of engineers, DCS commissioning or maintenance, verification test of the control strategy, the connected system can be utilized to avoid exploding equipment, for improving improper parameters, and decrease the cost of commissioning. After have a feedback from the another authors, the best instrument is DCS because specially designed control system used to control complex, large and geographically distributed applications in industrial processes. It also connected to both field devices and operating PCs through high-speed communication networks. Discrete field devices such as sensors and actuators are directly connected to input and output controller modules through communication bus. These field devices or smart instruments are capable of communication with PLCs or other controller while interacting with real-world parameters like temperature, pressure, etc. The temperature of ammonia to keep liquid is negative 33.33 degrees Celsius. So, DCS will keep monitoring the temperature of ammonia. DCS also access a large amount of current information from the data highway and monitoring trends of past process conditions. It also readily install new online measurements together with local computers, alternate quickly among standard control strategies, and readjust controller parameters in software. A site engineer can use the flexibility of the framework to implement his latest controller designs ideas on the host computer. As the plant is large and to control the ammonia is hard, DCS will make the engineer easier to control, and emergency shutdown also help the engineer. The important for DCS is to handle complex processes. DCS is preferred for complex control applications with a more number of IOs with dedicated controllers. These are used in manufacturing processes where designing of multiple products are in multiple procedures, such as batch process control. Next, DCS facilitates system availability when needed by redundant feature at every level. Redundancy raises the system reliability for maintaining system operation continuously even in some abnormalities while system is in operation. DCS offers many algorithms, more standard application libraries, pre-tested and predefined function to deal with a large complex system. This makes programming to control various applications being easy and consuming less time to program and control. It provides more number of programming language like ladder, function block, sequential, and etc. For creating the custom programming based on user interest, DCS can also monitor and control through HMIs, which provide sufficient data to the operator to charge over various processes, and it acts as heart of the system. DCS completely takes the entire process plant to control room as a PC window. Trending, logging, and graphical representation of the HMIs give operator to respond more quickly to the plant condition.
Assalamualaikum, my name is Nur Wafa binti Abdul Razak, metric number AA200459. So I will explain about the control system that apply in this company. First of all, control system have two types, which is DCS and PLC. DCS is distribute control system, meanwhile PLC is program logic control. The difference between both control system is DCS have four basic elements, which is PC or engineering controller, next distributed controller, then operating station, and lastly communication media. It is applied in data monitoring, logging, alarming, and controlling. Meanwhile, the PLC have four steps: operating cycle, first input, then program, output, and lastly communication and diagnosis. It is applied in trends, crushing, cutting, drilling, reactor, and welding operation. Between these two control systems in this company, they are choose the DCS system because it's ideal for large continuous process plant and its strong reliability and safety. The flaw of the DCS system is the signal flow from Human Interface Station (HIS) to field instrument. The controller will receive the signal and send to the system cabinet. Logic block present in FCS and signal sent to the I/O card modules. It will change the signal into analog or digital signal depends in question. Then it will send over prefab cable to merchant link cabinets. The output will receive. Last but not least, the signals of output will continuous travel to junction box. Junction box will pair the signal and send the correct section in field area. There is the UPS power provided to the cabinet component. UPS power is prevent the failure and in the cabinet have redundant. So that's all the reasons and the flow of the DCS block diagram of in the company control system.
For conclusion, it can be concluded that process control is essential in all operational systems, which can be achieved by identifying the related variables to help engineers understand the progress of particular plant. Other than that, establishing the appropriate system for the plant can also minimize unpleasant adverse occurrences in the workplace, such as fatalities or unwanted accidents. And last but not least, PLC and DCS both benefits in terms of economics, product quality assurance, equipment and work safety, and loss reduction based on how complex the process of one plant is. That is all from us. Thank you.